my name is Foster. I'm going to give you a quick brief over my term paper for 504 telecommunications class. Term paper is a shift to analytics on streaming data, and basically what it encompasses is how the shift is moving from like batch processing on historical data to more inline, streaming data analysis to get those insights that the information can provide a little bit quicker. So rolling into it with the agenda, we'll do a brief introduction, kind of let you know where we're coming from with the paper. The Internet of Things, we'll talk about it because it's a huge driver that's driving this transformation. The technologies that are involved in it, some of the driver industries that are propelling it forward. We're not going to talk about them all, for the sake of brevity, but we're going to focus in on the healthcare, telecommunications, the energy sector, and marketing, mainly the online, because online marketing is really where the time-sensitive nature of this comes into play. And then we'll have a conclusion, and I put a slide in there for questions, although in this format obviously you won't be able to ask questions, but once we post it online and we get to the discussion board, you'll have your opportunity for any questions that you have. So the introduction, like I said, traditionally when you talk about analytics, it was more batch processing of analytics on historical data, that was stored in some type of data warehouse somewhere. But what we're seeing, and when you did that, it was more of an iterative process where you'd run over the data multiple times, and you'd have to do a lot of what they call data munging or data cleansing to get the data in a format, that would be able to be analyzed. And a lot of people in the research industry, a lot of the professional data scientists that are out there, will tell you 90% of their time is spent on data munging. Probably 10% of their time is actually on the analytics side of the house. So that's kind of where we were. But what we're seeing is the decision window for a lot of these industries is shrinking. In order to keep and maintain the competitive advantage, they got to get this information faster, they have to analyze it sooner, and they got to make decisions. So that's one of the things that's kind of driving this shift. And like I said, is to maintain the competitive advantage in whatever industry that they're in. So we're seeing an increase in streaming data right now. The Internet of Things, which we'll talk about a little bit coming up, is really a driving force in this. All the sensors, the proliferation of mobile computing devices that is out there right now. And it's making a boom, I guess you would say, on the amount of data that's being generated and collected nowadays. So companies and organizations can capitalize on that data by being able to conduct rapid analysis on streaming data and drive quicker decision making. In that last little bullet there, fast food society, that's kind of where we're at right now, and it's kind of the American way. Yesterday is better than tomorrow. Yesterday is better than 2 weeks from now, which is what you kind of look at with traditional data analytics. So the Internet of Things, this is really one of the driving forces that's kind of driving this shift and this transition. As you can see up here, if you're talking about basically anything we own, we have chips in our pets to track them. It sends out data. Almost anything we have on our bodies nowadays, they're making wearable technologies. Although they haven't caught on yet mainstream, they're picking up traction pretty quick. Vehicles, driverless, cars, that type of thing is all going to be connected to networks and sending data. When you talk about agriculture in particular, this has been a huge driving force. I wasn't really aware, even though I grew up on a farm and a ranch, how much agriculture has gone towards analytics in determining, water, soil, temperature, all of that stuff, and the best way to get the best production out of agriculture. But it's huge in the Internet of Things, and it's only getting bigger. Energy consumption, the energy sector, that's one of the ones we're going to focus in on a little bit later. But when you talk about the smart grid technologies that are out there right now and all the sensors they're utilizing, they're creating an enormous wealth of data. Security and surveillance, I don't know if you saw it recently, but there were thousands of security cameras in Europe that basically got hacked and were used by bots, within a network to do, different nefarious activities, because all those security cameras that you see as you're walking in the store are somehow connected, normally through IP cameras, that type of thing. And then you got building management, you got telemedicine and healthcare. We're going to talk about healthcare in particular also. Smart homes, smart cities. In the US, we're seeing the smart homes right now. But if you look around the globe, I think it's South Korea actually built a smart city from scratch, pre-planned, where everything's interconnected, everything's monitored, and that generates a huge amount of data and a need for analytics. And then just the everyday things that we have smart TVs now connected to the web, our refrigerators, coffee makers, you name it, everything's going to be connected to the web. And then you got M2M, machine to machine, okay? These are wireless networks where sensors are tied together into their own network and then connected to the internet to report back. And all of these things in mobile devices, we already kind of hit on that with the proliferation. All of these things are creating this huge Internet of Things, as they term it. So some of the technologies involved in analytics on streaming data. Basically, you got in-memory computing, where instead of having to go out and query and pull data out of a database, everything's held in memory, makes it a lot faster to conduct your analysis. Then you got MapReduce, which Hadoop is just one iteration of implementation of MapReduce. And then you got some other variants out there like Twitter Storm that we'll talk about a little bit later. But all of these distributed computing type frameworks that are out there right now, basically with MapReduce kicking off the trend. And then on the database side, you got CouchDB, you got Cassandra, MongoDB, and a lot of other variants that are out there. Okay, non-traditional, non-relational database type systems, type database systems. So the driver industries that are out there. You got healthcare, which I said we're going to delve into a little bit deeper in the future, but basically you got these body area networks, that are put together with multiple sensors on the body that can send back real-time information on different things to monitor health. And we'll talk about that coming up. You got telecommunications. This is a huge, huge issue for telecommunications. Being able to analyze streaming data and react quickly to it. We'll delve into that. And then you got the energy sector with the smart grid, which we'll talk about, and marketing, online marketing in particular. So let's go into the healthcare side of the house. Like I said, you got these body area networks with multiple sensors throughout the body that can monitor everything from blood pressure, heart rate, temperature, O2 saturation, respirations, you name it. They pretty much have something out there that can monitor. So all these sensors are making like a little network on the body, and then they're connected, and they send that information back to wherever it's going to be analyzed, computed, in order to make decisions on, etc. Most of the stuff in the healthcare industry right now is built on a MapReduce framework with cloud implementations of it for the distributed computing. And these systems on a single body, can produce gigabytes of data, streaming data. And particularly in the healthcare industry, basically just because of what they do, the time window to make decisions based on the data they're getting is very short. They don't have the time to archive the data in a warehouse, go back and look at it. You got to analyze it as it's coming in so you can interdict, with medicine, doctors, whatever it may be, to save lives. And you got the telecommunications industry that produces a vast amount of data. You got performance logs, call data logs, customer experience data, fault reports. And basically what they're doing with all this information is they want to take it, and their main goal, particularly in the mobile area, is to reduce customer churn, customers going to other competitors. So they have a very small decision window because they want to have continued accessibility within their network. Downtime is definitely a bad thing for them. And the more efficient they can run that network, the more profitable it's going to be to them. So they have small decision windows with which to make these decisions. So you got one of the implementations that I put on here for you is Storm, which was started by Twitter and now it's open source through Apache. But basically with Storm, it's a variant, I guess, of MapReduce. It is distributed computing, but it enables you to do analytics on streaming data. So basically it's good for single pass, like clustering, where you only have to take one pass over the data set and you can come up with this cluster analytics off of it. And you can also do incremental algorithms on it, where incrementally you go over certain things. but you get real-time computation. So when you're talking about mean, max, min, all of those basic statistics that are out there that kind of drive analytics, you can do that in real time with Storm. Then you talk about the energy sector. You got the smart grid systems that are out there, and they're coming on quick. Basically, with these systems, you can forecast demand a lot better than traditionally you could, and you can also demand response programs. So as you sense more demand in one area of the grid, you can push resources to that area in response to that, and it kind of makes it a lot more efficient network. So when you look at the implementations of the smart grid, you're really looking at like the smart meters. So if you remember growing up, you had the guy that came around the neighborhood once a month, read everyone's meter, pen and paper, put it on paper, went back, and they did your billing off of that. Well, nowadays with the smart grid and smart sensors or smart meters, these meters are connected to the network, and they can transmit every 15 minutes on the usage. So it really makes the companies more responsive on where the high usage areas are, and they can allocate resources that way. And there are sensors all throughout the network, not just on the homes or the buildings, all throughout their network where they store this energy and move it around. So one of the implementations I saw on this that was really interesting is what they call a lambda architecture. So with lambda architecture, it basically takes the best of batch analysis and streaming analysis and kind of combines them. So what you have is the batch analysis kind of giving you this big comprehensive view, and then the stream analysis giving you these dynamic views that are updated as the streaming data comes in. So it improves the batch analysis with current data basically. So you got the batch layer, which manages the major data set, the data warehouse if you will. Then you got the serving layer, which pulls those batch views out and feeds it to whatever systems need them. And then you got the speed layer, which takes that real-time streaming data, conducts a quick analysis on it, and then updates those views in real time. So Apache Spark was the implementation in the paper I particularly was interested in. It uses what's called Spark SQL, Spark Streaming, MLlib, which is a machine learning, and GraphX for a database type. And basically you can process stream data, and with the Spark SQL you can also query against that data, which is pretty interesting. Marketing, I mean, you can go online at any time depending on how much you're online, but they got a profile on you. Even if it's just a couple of minutes a day, there's a profile out there built on you. And it's very pervasive, it's everywhere, and sometimes it's evasive if it gets overboard. You get online, you get 10,000 pop-up windows coming up. That's very evasive. A lot of privacy issues involved in it. But, they conduct this with clickstream analysis, which is real-time interest marketing. So as they see you online and you're looking for a holiday in Belize, all of a sudden you start getting these, hints, banners, pop-ups, whatever it may be, with offers, for vacations in Caribbean countries, whatever it may be. So that's real-time interest marketing. And then they do this through classification mapping as the information's coming in, interest and usage data mining. Not so much real-time, but there are real-time data mining implementations on streaming data out there. And mostly it's built around MapReduce and NoSQL variations. NoSQL meaning, not only SQL. So marketing is pretty interesting too. So in conclusion, what we have is the traditional analytics based on that batch processing, the data warehouse type architecture, that is very time consuming and takes a lot of resources to conduct. And this evolution, that's kind of ongoing right now, particularly it's going to be spurred by the Internet of Things revolution, where they're looking more at streaming data and how to gain information and insights out of that data quicker to make decisions within that shortening time window that a lot of these industries are having. The bottom line, I kind of went with this initially when I started the paper, saying that analytics on streaming data was going to overtake the traditional architecture, and basically what I found through research was they're basically just going to complement each other. One's not going to make the other one non-existent. They're both going to be here for a long time, but they're going to complement each other, kind of what you saw with the Lambda architecture. So this is where I was going to ask any questions that you may have. Obviously in this format you can't do that, so when I post it on the discussion board, feel free to put any questions and I'll be happy to answer them. Thank you.